And Patrick. Oh, Patrick, I need to give you probably permission to make co-host.
That's true. Oh, I have all the. Sorry, there's a bit of background noise from Automat. Automato.
Let me see. Maybe I can mute Automato.
Yeah.
There we go.
Okay, thank you. All right. I had opened this one, I believe. Yes, you can see the backstage micros right now, I hope.
Yep.
So I think I'll just kind of go and stop me if you have any questions or want to take the discussion in any other direction. But we'll start out with just the tooling, kind of how it works, how it's set up. And also just where to find more information of it about it. I'll start actually in that end. So on the microsite, we have the local development section, the CLI. There's an overview here, which introduces kind of first, glossary, what we consider these terms to mean. I will be talking about bundling and building, for example, where bundling is kind of Webpack, but we also do it for the backend. It's the process of building something that is shippable and deployable into production, you could say, or typically production, right? But a deployable artifact. While building is building an individual package, typically for publishing that package to npm. And the build system is kind of set up around those two main things. Overall, so we have design considerations. We ship all of this through the backstage CLI, right? Which is internally, of course, uses Webpack, it uses rollup for a lot of these things that we want to do. It forwards to just for testing and ESLint for linting. I'll keep it light on those bits and focus on the build tooling right now. But we want it to be it's a monorepo setup. We want it to be possible to publish individual packages at the moment, and to be able to ship things like that from npm in a repo that is also used for other things. So it's kind of the system is intended to mesh pretty well between packages that are published and applications that are bundled and deployed. We want it to be very scalable. We have a very large monorepo internally. We are going to be looking at like ways in which we can break down these repos, but either way, scaling is kind of a priority to be able to support large repos. And that just means that some of there are some design decisions where scale is a limiting factor. For example, we chose to have everything be one huge TypeScript compilation bundle, and that is because of scaling constraints. And when you run TypeScript sub-projects, at least when we evaluated this a bit back, if you split things up into separate smaller projects, at the TypeScript level, the build times just skyrocket and don't scale. Like you're saying, build times of 10, 20 an hour to compile the project. Right. We're trying to have a system where you can build both isomorphic packages, front-end and back-end packages with one system. We don't necessarily target, and that's at the build system level. We don't really have a runtime desire to run all of this at runtime at the same time at the moment. But the build system kind of somewhat seamlessly just functions with all of these different ways of building and using packages. Yeah, some other things like modern environments and so on. One very core thing that we do, and the developer experience in the repository is in the project is a high priority. We want it to be possible to essentially go in, write yarn dev, and then start writing code and start making changes. So there should be no need to, and especially with tight iteration loops as well, right? So we avoid building packages during development at all. We do all development straight from TypeScript source, and we've set up both front-end and back-end to do transpilation on the fly of all of the monorepo packages without needing an intermediate build step. And I know at least that when the Backstage project was set up, that was a fairly uncommon thing. Many monorepos had the setup that you had to build the packages. You could develop on one individual package, but you had to build the packages to like try them out as a whole. So that's one of the things that we very much wanted to avoid, and I still consider a constraint that you should be able to just go into the repo and start development without a lot of like ceremony to get started. Is that helpful so far? Is there any direction you would like to point me in? Otherwise, I will just dive a bit into like the tech stack, I think, of the CLI.
Yeah, let's dive into the tech stack of the CLI. I think like for a generic overview, this is good.
Cool. So let me think for a second about the best place to look at this. I think we will just jump into a bit of code, into the CLI package, and just kind of see the setups of these things, because as I mentioned, it's basically Webpack and rollup that we use. So and Webpack is responsible for the bundling. I think I'll leave backend out of this completely for now, because it would just complicate the discussion, because we do use Webpack for other things there right now, but I'll just focus on the front end and what the front end setup looks like. So yeah, it's divided into building and bundling. As I said, building, that is when you want to publish a package. It is not used for anything else, almost ever. So the foundation for that is rollup. Let's see what the configuration setup looks like. It is really not that large. So we have a setup that produces a rollup config, and it's tied into the kind of primary way in which we configure the packages. Like we generate a rollup config is this package role that we have for every package in a Backstage monorepo. So let me see if I can find that. Sorry, I'll jump over to documentation again. Here we have the different package roles that exist, and this is something that you declare in the package JSON. So you can say that the package is a front end, which is like the app, a backend, again, entry point, the thing you deploy, CLI tool, and then more interestingly here for the building, different library packages. So it is only these packages that actually that building is meaningful for. Well, shipping the CLI as well, but these are library packages, so to speak, where you build something and you can publish it. So you can see we have, for example, web library, node library, and common library. So jumping back to the rollup configuration, there's logic that just determines, okay, we have a web library. That means we need to only produce ESM. And then we set up an ESM build. There's a logic to say if it's a node library, we only need CommonJS for now. Well, and this is why we have this indirection. One of the reasons, so that it's set up to be able to evolve as the ecosystem changes, and we start producing ESM for backend packages and so on too. Other than that, yeah, we have a like kind of fairly hard-coded list of just file extensions and transforms that we have for different types of assets. We keep those in sync between the Webpack config and the rollup config manually. And that's how we set that up. We target a TypeScript or ECMAScript version that we bump every now and then in accordance to our Node.js release policy, really. As Node tends to be the one that is the furthest behind. Browsers tend to be far ahead. Yep, so that's the rollup configuration. It produces, I can't show this here, but for any package, it's going to produce output in the dist folder. That's separate. It will produce common. It can produce common.js, ESM, and type definitions as well. So that's an important part as well, of course, for any package that has an external TypeScript interface. It bundles up the type definitions of the package as well and make sure that's available. Webpack wise, I don't know. It's fairly straightforward. There's some trickiness we do because of monorepo development, where we make sure the resolution happens correctly when you're requiring modules from other packages in the backend space. But front-end wise, it's a fairly common Webpack setup that we just like have some extra added some flavor to it. For example, the config injection we have, and this is important, of course, the chunk splitting. This is one of the reasons we are still using Webpack, I would say. I really do want to switch over to something like ESBuild. But Webpack has very good chunk splitting, being able to get the dynamics chunks out. We also very aggressively like reduce the modules down into smaller chunks to be able to kind of cache them aggressively in the front end, so that we don't have one big vendor bundle that as soon as you change a single dependency, the entire bundle gets invalidated and you have to download it all again. We split it up into way smaller chunks of dependencies, so that when you just bump React, for example, only React needs to be downloaded again. Transform-wise, we use SWC, we used to use Sacrace, we use ESBuild in the like TLDR of the transpilation process is we use whatever is the best tool at the moment for what we need, and we've switched around a bit, and it we'll see if SWC ends up being it's really good right now. Hopefully we stay there for a while. We still use ESBuild in the rollup piece because it produces nice code and is very fast. But SWC, of course, is the only one that has fast refresh, React fast refresh support. And we stay far away from Bobble, for example, because it is very slow once you reach scale. I think the very last thing to cover that's important is the publishing step, so I mentioned that in local development, we do development straight from source, right? And that means that, oh, I'm looking at a bad package here. Here we go, config package, for example. Main types, all of this points to source. This is, of course, not available in the published package, or if it was, you wouldn't want to use it. So these fields are rewritten when packages are published, and that is done in the pre-pack script. So essentially, this is going to get pointed over to the dist folder instead, types as well. This is currently done through this in publish config. The fields here is how you configure it. We are kind of slowly moving over some packages, at least, to use exports instead. And there we, rather than having it in publish config, we rewrite these export fields to point to dist with appropriate, import require type default flags here within the exports field, but still develop from source. That's main thing for the build system. The jest setup is basically just a mirror to make all of this work as well. Basically staying in sync so that we can test the same sources we are building and bundling. So anything there? How are we for time? Should I dive into the front end system?
Yeah, let's do the front end system now.
I will keep it brief. Let's see where we have information. So plugins, composability system, and yeah, as I think I've mentioned before, we do want to give the front end system some more love, and we'll be able to. I think especially now that we've overhauled kind of the backend system, the front-end documentation is a bit leaves some improvements to be made to it. Same, but the current front-end system is built around, so it's plugins, but extensions are really the most important thing. So this documentation that you find under plugins composability system, that describes all of it. Jumping into some actual code with examples. To build a Backstage app, everything is in the app package. This is what you build. This is where you wire everything together. This is a ton of imports of different plugins. And what we're importing here are extensions from these plugins. So we call these things extensions. It's, for example, the Explore page. It's the GraphQL page. Here we're seeing a lot of pages as we dive into different parts of the app, such as the entity pages, which I won't dive too deep into, but here we have entity, has components, card, for example. These are all extensions that are being imported from plugins. The idea is that the plugins export a number of extensions, and the integrator who essentially writes the code in this application decides what extensions they want to import and install into their application. And as you're installing these extensions, you also you have to put them somewhere. So for these pages, you install them at a route. You can also, for some of them, it's just a very plain kind of, you just put the page there and that's it. There's not much to configure. For some of them, we see the tech radar page here, for example. There's a little bit of lightweight configuration. And then for other ones, there are kind of a lot more configuration that you can do. Like the scaffolder, you can pass in additional custom field extensions that are used in the scaffolder UI and so on. And this is why we call it a composability system, because we're composing, we have an app where we're adding the scaffolder plugin or an extension, a page extension from the scaffolder plugin. And with that page extension in turn provides extension points for other plugins to provide field extensions that can extend the scaffolder plugin. So sounds complicated, but essentially it's just, you know, stacking stuff on top of each other and composing pages and features from various plugins. But right, an important thing there that we want to maintain is the fact that a plugin is not simply a page, it is a page that can in turn expose additional extension points for other plugins. Yep, what it looks like on the other end. Sorry, did someone have a question? Yep.
Well, I had one question. So
Yep.
If an extension is giving extension points to other plugins, how is the dependency management then? Like, I'm
When
an
you say
extension.
dependent, do you mean
Right,
like
it's just the packet JSON?
What typically happens is that you have, for example, let's say scaffolder. You have the scaffolder plugin who exposes and that is a package. So there's the scaffolder front-end plugin package that exposes the scaffolder page. Then there is an accompanying package, which is the scaffolder React library. So it's the front-end library for the scaffolder. That's a separate package that other plugins who wish to build upon the scaffolder can install. So there's no direct dependency on the scaffolder package. If you want to build field extensions, you're instead depending on the separate web library that the scaffolder provides. And then that is all wired together in the app. So the app is going to have the dependencies on the different field extensions that you want, and of course the scaffolder plugin itself.
So extensions don't know. Okay, just let me recap. Basically, app knows the dependencies between extensions and not the extensions among themselves, essentially.
Yep. And here's under overview, architecture overview, package architecture. This describes the relation between the different packages, the types of packages that exist. So you have, for example, the different plugin backends, and then the library packages, and how other packages can build upon this. All right, then
The time check. Other things. What would you like to cover? We have let's do maybe a few more minutes. Just to make sure we could give Red Hat folks enough time to talk about theirs, and then leave some time for action items at the end.
Yep. There's really one piece of code, if this would load, that I just want to show, and then unless there are questions, I don't have anything I want to point at this point, at least.
While it's loading, should we mention the API refs? Is that worth mentioning for the front-end framework?
We can do that. So another one to point at, utility APIs. And that's a good one, thank you. So hopefully, yeah. So utility APIs, it's kind of a solution for more non-visual bits of plugins. But how do I explain it? It came out of the Backstage core framework providing a lot of utility APIs for plugins to use. I'll admit, Freben. For plugins to use. So it's stuff like the auth APIs, the error log, the error like notification thing, various different APIs that you would use. We have there's a general pattern of building these APIs that we have internally. So it's shared APIs for plugins to use. They are exported as interfaces, and they are API references that you use to access the concrete implementation of the APIs. It's decoupled from React, but you can consume them in React using hooks that we provide so that you can access these APIs. Plugins can also provide their own APIs, and it is fairly common that they do that. So the scaffolder, for example, has a scaffolder API ref here. It provides that as part of the plugin. That means that components within the scaffolder can use that API to implement their functionality. If the API ref is exported from the plugin, if it's internal, it's just an internal utility. If it's exported from the plugin, it means that other plugins can potentially rely on this API and use it themselves. And it also means that you can override this API in the application so that you can either decorate or completely replace the implementation of the scaffolder API with your own implementation in the app. And that is a fairly important customization point in some cases. We're constrained for time, so I'll point at just how these extensions are created that I mentioned before. So you have, for example, the scaffolder page. You can see here it's a scaffolder plugin. It provides a routable extension, which we create here. There's a small API for what it is. In reality, it's very much just a React component that we couple with a framework. We just hook into the point of exporting this React component, and we're able to decorate it with additional stuff like the plugin context, error boundaries, and so on. So this is a nice container for the extension, the component that is being exported. Components don't have to be, extensions don't have to be React components, but they very often are. And I'll leave it at that.
Let's do 2 minutes of questions, and then Red Hat folks can take over. Any other questions before we transition to the other topic?
Hey, Patrick, I was curious if plugins are exposing APIs for other plugins. If plugin needs to make a breaking change to an API, where is that handled? Is there any way to depend on specific versions or in any way that's managed in Backstage today?
You're not allowed to break the consumption of API refs, the consumption side of the interface. If you want to do that, then create a new API ref, unless you know the plugin is in an experimental phase. So you would just do a scaffolder v2 API ref. It is fine in our version policy to break the producing end. It's fine to break the app because the impact of not allowing that is bigger than not allowing it. because it actually makes the consumption just way more complicated. So if you want to add a new method that's required, you can do that. And that's, of course, won't break consumers.
Any other questions?
Det är katastrof i Andreas. Vi kan redan bestämma det. Du får inte säga ordet varför. Du får inte ställa saker. Du får inte tjata och tramsa om saker.
Okay. So,
I'm hearing Freben, I think.
Och så. Små enkla saker. Starta inga debatter.
Should I mute?
You could do that, just in
All right.
case.
Okay. All right, folks. So let's switch over. Thank you, Patrick. Let's now have who would like to present from the from Red Hat side.
I'm gonna say a couple of words and then I'm gonna hand over to Martin. So can you present?
Yeah.
Okay.
Martin. Oh yeah. Okay. Here we go. Got Martin.
Yeah, me.
Yeah. Got it.
So as we've talked about before, we would like to introduce some way of adding, extending the front end, and using new plugins, removing plugins, adding them, upgrading them, whatever that lifecycle management of plugin means, through configuration, not through code changes. And why we want to achieve that? Essentially, we want to provide an easier way to maintain Backstage images for us if we have a diverse set of users, of instances, and we don't want to maintain 20 different images for 20 different instances of Backstage. How we set on a way, like how to approach this, how to handle this, we've turned our attention to other projects in Red Hat who utilize a similar fashion, who solve this through Webpack Module Federation. And very recently, we've broken off this extendability piece into a separate framework called Sculprum. And what we did since our last meeting is that we've put together a very rough RFC, which is still in work in progress. I've just filed it before this meeting, so you didn't have time to look into it. Sorry for that. You can find it here. And what we also did is a short POC showing you the capabilities, how we think of like a way to load remote components, remote code through Webpack Module Federation. And we can talk how we got there, talk about how we got there, what we did to achieve that, and what challenges are still ahead of us to solve to make this fully functional for full Backstage consumption. So I'm gonna, if you have any questions during the demo or anytime, just feel free to jump.
Yep.
Over to Martin.
Okay. Before I start showing the demo, I'm not sure how familiar with you are with Module Federation. Should I do some 2-minute crash course, or can I just jump in?
2 minutes might be good, just to level set everyone's understanding.
Right. So I know that you mentioned you want to move away from Webpack. Well, we have locked ourselves into Webpack a couple of years ago. But basically what the Module Federation allows is this is super simplified description, but you can imagine it as give the ability to developers to import modules that are not locally installed on your machine anywhere. That's very rough description, but essentially Webpack allows, let's call them different submodules which live on different remotes, to be pulled into the browser at runtime or node environment at runtime. And in addition to that, it provides a module sharing capabilities. So you can get around potential issues, downloading the same module 10 times into the browser, right? You can imagine every module depends on React, but there is no point of downloading the React asset all the time into the browser. So with the remote assets and the module sharing, you can essentially allow, I don't want to say compile or build assets at runtime, but technically you can import remote components at runtime that have been already compiled and essentially create an illusion that you are running a monolithic UI, even though all these assets are being built, deployed, and developed separately. Right, I think that's kind of the very short description of module federation. There is a lot of details when you want to learn it and use it, and unfortunately the Webpack documentation does not do a very good job of documenting the concept, but there is a lot of examples, fortunately, and that can help you figure out what they mean. And basically what we did in the other products, we have our hybrid cloud console front end basically running on this. It's a microfront architecture. We have over 60 different micro applications with many more remote modules, and we have been successfully running on this for the last 2 years. And it has gave us the great opportunity to develop and scale very rapidly, whereas I can't imagine how quickly we would be able to achieve this having some sort of monolithic architecture, I guess, or package-based architecture. So as Tom said, we have basically managed to create a simple POC. I'm going to share my screen and show you what we did. Can you see my screen? Okay, good. So what we did is we took the Scalprum framework, and added it into the Backstage front-end code with all the configurations and everything. And what you're looking at right now, basically we took this rate this entity component, and on the left side it's being loaded as you're used to, and on the right side it's basically being pulled from a remote CDN, if you like. We have just running a local simple HTTP server running locally. And basically you can imagine if I would now change this component entirely, I wouldn't have to run the whole application build. I would just have to build this little module, deploy it to wherever it's supposed to be deployed, and a user would just have to hit the refresh button somewhere in production, and suddenly they would get this new version. So I'm gonna show quickly how it looks like in the browser and what the browser does, and then I can show you some of the code and how we achieved this integration, right? So if I just hit refresh, it's gonna do things a bit, and you might not have noticed, but there was slight delay before the component was rendered. And what basically happens is there is this manager of these plugins. Every single plugin has a manifest like this. It basically has some metadata required for the plugin manager to initialize and render the component. You can see it has some base URL and some load scripts entities. This script is basically the entry point to the module itself. And once the script is added into the browser memory, it initializes the container, it exposes the component, and you are then basically able to load these modules. The plugin store provider here is essentially the manager, and it has lists of all plugins. We only have the one Backstage plugin. And this entry module here, these get and init functions, you can imagine as this is what you get when you write import component from B, right? So basically this get function, this is the module itself. If I were to store it in the browser, I can just call it. Oh, how did we name the function? Like dislike button. Oh, dislike button.
You have missing E.
Thank you. No, it's probably a different name. I can just quickly scan for it. There it is. Buttons. Yes, sorry. And if you have ever played with a there we are. If you have ever played with Virtual DOM or anything, you can see that suddenly we have these components, and they are basically just the React components themselves. So I have successfully imported component into browser at runtime without the module being available at my node modules. Right? And all our applications in the hybrid console are basically these little submodules. They are not just applications, but individual components are exposed as well. There is also a concept of extensions when I can say, okay, I want all, let's say, pages with this ID, and suddenly the browser would load all of these extensions. You can, for example, imagine all of these tabs as extensions, which I believe is probably quite similar to whatever extensions you were talking about earlier. Right. So that's the main concept. Plugins and extensions can be developed, built, deployed independently. There is no global build of anything. There's only a host application that manages these plugins and loads them to the browser. And then through configuration files, we are basically setting up the environment. So we have one code that runs on multiple different environments, and these environments are being customized and modified based on configuration, not based on code. This is something that Tom was talking about. So how did we achieve the integration with Backstage? It's, well, thankfully, because you are using Webpack builds, it was quite simple. So apart from installing the dependencies and etc., the main thing that you have to do is you have to set up the module federation. Obviously, there are two types of module federation setup that has to be done. One is for the host application, for the application shell, for the module manager, and one being for the modules themselves. So for the application manager, it's extremely simple. You just have to create a module federation plugin into your Webpack, add a module federation plugin into your Webpack config. So these few lines essentially created that plugins, and then we just pushed it to the existing array. We haven't changed anything else here. Everything else stayed as it is. And because of how React works and how the React, specifically the React context works, you also have to make sure that you share some modules. The most important modules are obviously React and React DOM. And then we have these two modules, Scalprum React Core and OpenShift Dynamic Plugin SDK. Now, just a note, we are in a kind of transition phase, but we are planning to move the Dynamic Plugin SDK into the Scalprum organization sooner. And another thing that you have to do is mark them not only for module sharing, but also as a singleton. And the case for that is if I build my application independently, there is going to be an issue that it will not have the access to the same instance of React context as the other independent plugins. So Webpack thankfully gave us this option to mark a module as a singleton, which allows sharing the context, the instance of the package between all of these modules that live in the Webpack shared scope. Right, so these are the necessary steps to enable it in the host application, in the shell application, which was here, as I said, new plugin, and added into the plugins array. And then in the plugin itself, we have this dynamic remote plugin that comes from the OpenShift dynamic plugin SDK. It should mostly use the same share modules. It has to use the React, DOM, Scalprum, and SDK modules as singleton and share them. Anything else depends on the environment and the requirements. And then we have some plugin metadata, which are defined as a simple JSON. I'm not sure where this source code is. We have tried to add it to the YAML file, I believe, Tom, right?
No, this is the plugin and the package JSON.
Oh, right. In package JSON, yeah, we added a plugin metadata.
No, it's Scalprum key.
Scalprum what?
Scalprum key. JSON.
In package JSON. Here. Yeah, so basically you give a name to the plugin. For Webpack implementation reasons, the name cannot be the same as this name here. That's because of some specific limitation of the container naming. You cannot use some characters for remote containers, so that's why we cannot use the same name. And then you essentially tell what exposed modules are in the remote module, in the remote library. So right now we have only like and dislike button, but you can list 50 or however you want in the configuration itself. Again, there's also the concept of the extensions. We haven't showed it right now because it takes a little bit more time to set up and demo, and we didn't know how much time we would have. But what this means, essentially, I am now able to reference dislike and dislike buttons in the wherever I want in the host application, and also not only in the host applications, but also in the plugins or plugins themselves, right? So it's not a flat structure. The like and dislike buttons can also consume modules from other plugins, etc., etc. So how I can access my plugins, or how I can enable the Scalprum plugin manager. In your host applications or host application, you have to set up the Scalprum provider. This Scalprum provider is just a simple, React provider, as you are probably used from many other modules, and it requires only one configuration option, which is a configuration file. And it's not nicely here, but essentially, if we can look at the raw structure, it's a JSON object which acts as a registry for the plugins themselves. And how it looks, it's a very simple structure. You have to give it some name, and you have to give it a manifest location. The manifest location is the entry into the remote container itself.
Can you show how it's defined in the app config YAML?
Right. So we have tried to use your existing files, and basically this is how you would define your dynamic plugin in the app config YAML as you have it right now. It's we try to make it as simple as possible. In our environments, we use this object to also define some additional information, some routing data, some instance-specific properties, etc. But at its core, it can be as simple as this simple name and location of the manifest, which holds the remote container entry metadata. All right, so this is how you define it and configure your plugins. And then we have this React binding. Simple React component requires two attributes. Scope is the name of the plugin, and module is the actual module that you want to use from the plugin itself. there are some additional props for the component, like error handling, loading states, etc. But any non-Scalprum specific props will be then passed down to the component itself. So the component doesn't have to be an enclosed React component or anything like that. It can define its own NPI and have required arguments. But in this case, we used the existing like and dislike buttons module, which didn't have any interface, which was just fine for us.
Just to piggyback on that, the Scalprum component itself, as you can see, not everything is happening through configuration as of now, right? So our end goal is to also be allowed to instantiate these Scalprum components from the remote locations through the app config YAML, which we want to achieve through like user configurable mount points, basically allowing user to specify mount points in their front-end application, like saying, I want a new tab in the entity page, or I want a new menu item in the sidebar rendering a completely new page, and things like that. And that would dynamically load those mount points from the appconfig.yaml through this Scalprum component, basically just iterating over whatever components you list in the appconfig YAML.
Yep. I know we are running out of time, so the last point that I want to show is the Scalprum, the Webpack configuration for the, because we have to add the Webpack configuration for the plugin, because as far as I know, and I'm very experienced with Backstage, I saw it for like 3 hours. You are building the plugins with Rollup, which obviously Rollup and Webpack will not be compatible. So we have to add a simple Webpack config for the plugin itself. We tried to reuse as much of your existing configuration as possible. You have mentioned before the chunk splitting. Now the module federation is probably even more aggressive than your current setup is. And that's because of the module sharing. So every single shared module is basically its own vendor package, if you will. And it can go very, very deep, even on a component level. And that's what we are trying to achieve at Red Hat, that we want every single component to be its own package. And so the network overhead is minimal between the shared modules across the different plugins. But as you can see, again, we used whatever you had for your Webpack configuration and then just added the dynamic plugin into the plugins array and run a simple build. And it worked, right? Then we just had to just simply host the assets with a extremely simple HTTP server. And we have now everything working locally. If I just go in, add some text here, I'm gonna just rebuild it and rehost it, and it's gonna work, right? And this is how you can imagine a dynamic plugins would work. The core application would stay the same. The separated plugin would be built, would be deployed, and as soon as it is deployed, then the core application, the shell application, would have the updated version of the plugin without any, project-wide builds, deployments, or anything like that. So you can be very granular when you're working with your plugins. I think I haven't saved it, so it's not going to be rebuilt.
In addition to that, what we're adding as an overhead for the plugin maintainers, plugin developers is fairly minimal. The only requirement there is to specify that key in the package JSON and the list of the exposed components in there. Right, nothing else is required from the plugin developer to do. No code changes anywhere, except from and that comes from the Webpack module federation requirements that exports needs to be default. It needs to be a default
Yes.
export on the component, right? You can't federate something that is not a default export.
Well, that's more of a React lazy limitation than module federation, and we are using. You can see that the stuff was added here. It was added here as well because you mentioned, you know, you don't have to rebuild stuff during development, but if you would imagine this as a production environment, this entity on the left would still be the old version. This entity on the right would have the new version because we don't need the root application rebuild itself.
And just back to the build process, to what needs to be done on the plugin developer side, basically just the presence of this Calprom key in the package JSON adds another build task for that particle package. So the particle package, a plugin, is built in two different ways. One is the standard roll-up building into the list folder, and the other one is a Webpack building into the dist Calprom. So you can still use the plugin both ways. You can host it as a micro frontend from the dist Calprom, and you can install it or publish it as like a normal Backstage plugin through the rollup config, as you may be used to.
Yep, I think we ran out of time.
Yeah, we're out of time. I actually have to go. I have another meeting starting like right now. But I made Patrick the host. So Patrick, can you like close off the meeting? I think we just need to figure out if there's questions, and then if there's any action tasks to take, and we can set up a follow-up conversation for VMware folks to show their work, and then figure out what the follow-up actions will be.
Sounds good. I can stick around for another 15 or so. Is that all right? Right, folks?
Yep. Okay, I'll let you folks continue. I'm gonna I'll stop. It should continue recording until the end of the meeting, so I'll watch the rest afterwards.
Okay.
Okay, bye everyone.
Thank you. Bye. Thank you. For running through it. It gives me a lot more context. I think in my head the two like trickiest bits of this is the composability and like how you configure it, how you provide a good experience there and a good system for like how that works. And the other thing is,
Oh, go ahead.
And the other thing is the federation system or the build system in combination with a good local development experience.
Right.
Also including when you're like building a plugin in a repo that is separate from the main Backstage repo.
Yes. So this is something that obviously we had to tackle on our side. So specifically what we do in the hybrid console, we essentially have a development environment, right? And then if you want to develop a plugin and actually want to develop it within the environment, right? We have a just local proxy setup, which hooks into the deployed environment. So everything, because the application is huge, right? There are APIs, you know, multiple front ends, and if you were to run it everything locally at the same time, you would probably need a spaceship to run it, right? It's fairly difficult to, it's very resource heavy to run the whole console. So that would not be feasible. So what we have this development environment which everybody is developing against, and they can run their UI locally, and they can develop their specific piece. Now within the development proxy, we also have the option so we can run multiple different UIs at the same time. You just have to tell your environment, you know, whenever I want to run plugin A, it's available at localhost, I don't know, 8005 or whatever. So that's how we handle the development.
So sorry, does the plugin then get kind of injected into the production application, effectively like replacing what is currently there
yes.
with your own modules? Yeah.
we are basically rerouting the requests to the assets to the local machine.
Right, because you're visiting the main app, but
yes,
then instead of going to grab the production version of your plugin, you grab the local development one.
yes,
Yeah, makes sense. Cool, and that still is, I guess that's fairly, it's still a bit, does that work with like React Fast Refresh, for example?
yeah, it does work. Yes.
Nice. Because it's effectively serving a development bundle from there rather than a like built thing.
Yeah, the Webpack dev server is still hooked into the browser, right? So it just, instead of running from the actual root of the application, the fast refresh essentially starts at the application entry point.
Yeah, that sounds like a nice solution. It's still like complicated to set up, but it sounds like a good solution that can bring at least similar, really better development experience if you're considering a large Backstage repo. We have to weave the backends in there as well, but that's kind of simple with when you already have a proxy locally.
Yes, and for the composability, so we are kind of in transition period when it comes to composing the environment itself. So in the past, we had these static files, configuration files, and we essentially defined, this is the list of all available, let's call them micro applications, not just modules, because the micro applications can also expose modules and extensions and etc. So we have this list, and in this list, each module has its own entry, and within the entry, we say, okay, module micro application A can be on route, B, C, D. Like it's not limited to just one route. It can be on multiple routes, and each route can have can use different entry point from the micro application, and it also can have some different configuration. One is for the one set of the configuration attributes is for the shell application. The other set of the properties is for the component entry point itself. So you can imagine it as some sort of initial props of a component whenever it gets mounted, right? So that's the past. Now we will stick with this format, but before it was static, and now we are moving into a Kubernetes environment where every application will have its own custom resource. So instead of having a central repository of this configuration, each application will own its own piece of the configuration. And during the build with OpenShift operators, we will compose this main configuration file and then serve it in the environment itself.
So what it means for like what all of this means for our Backstage experience is kind of different, right? Because we can't limit ourselves just to like these Kubernetes viewpoints.
Because these are the foundation of product strategies. Our ability to meet.
Sorry, I muted Gorkam.
Good. So we don't want to limit ourselves just to like Kubernetes deployment, because we know that all Backstage users are not just Kubernetes users, and people are running it in different fashions. So we want to preserve this like of a static configuration type of experience that everything is configured through the app-config.yaml. And since we know that each Backstage instance can look completely different to another Backstage instance, right? Want to offer some sort of a mount point logic and helpers that like the integrator who's creating the Backstage instance can define what mount points he uses and where he uses them. So imagine like in your entity page, you put like a listener or fetcher for this particular mount point, saying basically, import me all the components that I have in config file for this particular mount point into this particular place. And in different page, in different part of the DOM, I can have a similar thing for a different mount point, which kind of gives the integrator freedom to specify the mount points himself, but also once those mount points are specified and solidified, you can dynamically change what's displayed on those mount points through the app.config.yaml.
Yep. And there are just some like weird, small, tricky bits that I find. Like, how do you, for example, you remember the tabs on the entity page?
Yes.
How would you handle ordering of those tabs?
Maybe Sam can answer that question because they're actually using that in OpenShift.
Yeah. So the way we've done it, at least for like the left nav, so we have a left navigation with various menu items organized by section, is and this isn't perfect. We have like a insert before, insert after properties when we define that extension point. So you can say, you know, I want to add this nav item and insert it before this other one. You still have to figure out, like, if two plugins are trying to insert an item before the same standard nav item, like which goes first. So we fall back to just like alphabetical at that point, like if there's a tie between them, so that you have like stable ordering, so that if you refresh the page, you know, it doesn't start flipping back and forth. Yeah, that's the approach we're taking to this point. So I think for tabs, we could do the same thing potentially, right? You know, say I want to be, you know, inserted before or after this tab.
So what we did in the hybrid cloud console is that we give the individual teams and micro applications, you know, the ownership of their configuration, including, for example, navigation files. But then the shell application itself controls where these pieces get inserted, right? If that makes sense. So let's say that, you know, the application says, I want my navigation item to be visible, and, you know, whether it's expandable, static, whatever, that doesn't matter at the moment. But they tell us, okay, we want to be in section A, right? And the shell application itself has some sort of templating for the section A, and inserts, based on the IDs, inserts the item at its correct place, based on where, you know, the product management and user experience teams has decided that the application should live, right? Because if you want to have,
sorry, just conceptually, from the point of view of the one configuring the layout or the integration of all of the plugins, are you taking extensions from plugins and putting them on mount points? Or are you saying, I want this plugin, and then it will automatically go on the mount point that it knows it should be in?
Yeah, so part of the, again, not talking about hybrid cloud console, not OpenShift, because that is slightly different. But in our hybrid cloud console, the micro application itself tells us on which routes it is supposed to be hooked on, right? And then we take this
information. So route is simple. So route is simple because it's kind of unique, but if we're dealing with like composing pages.
Well, that we are giving this freedom to the micro application itself, right? So if I want to use a module from different micro application, right now I have to specify, you know, where I use that application and when I inject it into the front end. That is hybrid cloud console. We haven't fully embraced the extensions. The extensions part of the Sculpt room, which are generic extensions, say I want tabs, so it will give you all the tabs. That's the part that's actually coming from the OpenShift console in that sense.
Because I know early on or like what the internal version of Backstage had before open sourcing was that it was all plugins and plugins with pages, and then the plugins that, you know, where there was composition going on, essentially had a plugin registering a page and then just importing from other plugins more content that they needed. So is that fairly similar then, that you have a micro application that's a page and then they kind of just grab?
Yes. Yes.
And so that is something that we had to unwind for the open source, because all of a sudden, this page is no longer something that you can just give someone and assume is correct for everyone. You actually need to let the integrator pick, what should appear on that page, which is particularly relevant for the catalog, of course.
And in OpenShift console, we've done this by defining the different extension points to say, like, here are the various places in the UI that you can extend, and then the plugin says, no, I have an extension, I want to use this particular extension point, whether it's like the nav, or I want to add a new page, or whether I want to extend an existing page. Like I want to add a tab to this specific page, or a card to this dashboard page.
And the question that pops up in my mind is, like, how far do you want to go with the abstraction, right? Do you want to say that you have extension points that have various types, like supported types? You have extensions of various types, and the ones that are compatible can be matched together by the integrator. Like that, you can go pretty far and potentially overkill with how much you encode into the system, I guess. So that's like tricky design decision.
Or is it more about
how
we use it elsewhere? Are you asking about how we should approach it in Backstage, or how we use it elsewhere?
I'm just thinking about this kind of system and how it would, well, what it could look like in Backstage. Right. That there's just different ways to do it.
I don't think in Backstage we can go this far that the plugins decide where to display themselves, simply because of the fact that each Backstage instance is different, and can have, like, you can have a catalog mounted on a different route, and that can break all the extensions deciding that they want to be displayed on this particular route, right? So we want to, or at least that's what I'm thinking about. We want to give this power to the creator of the Backstage instance to decide where they consume given mount points. And these mount points are just key names from the app config YAML, where you specify what to be displayed on that particular mount point. So, like, the creator of the Backstage instance decides where the mount points are, and if you're like configuring it and adding new plugins, you don't need to change the code, change the React components, the structure there. You just add a new entry into the app config YAML with that particular mount point.
But I would want, like, plugins to be able to have mount points themselves where, extensions can be installed.
Yeah, I mean, we don't see an issue with that, right? So yeah, I think this kind of comes hand to hand, just placing a lot of trust into the plugin developers, right? Because suddenly they have this power to essentially inject a whole new application into their plugin without the, let's say,
they can already do that.
Yeah. So
doesn't matter. Yeah.
Doesn't matter.
Yeah. No, there's definitely some guardrails that might be needed in some places. Okay, let's. I think it's time to wrap up, right? It's beyond time to wrap up. So one thing is actually from our end, from maintainer and also Spotify end, it looks like this is getting on the roadmap, and that this is like the overall removing the need to change code to install plugins is something we'll be able to prioritize and work on.
Yeah, that's great. So because we've got notified, or Tom told me and Sam about this requirement, we went all gas on properly open sourcing the project itself, right? So it was internal project, there wasn't many community documentation, etc. I also mentioned that part of the code lives in the OpenShift organization. We're trying to move it and move it into the Scalprum organization, so in 1 place, prepare demos, documentation, everything. But the problem is that, and this is something that we discussed internally, is that we don't have enough time to do that, right? So we have a lot of But as I said, it's been running in hybrid cloud console for 2 years. So, you don't have to be worried that it's not stable, it's experimental or anything like that. There is more of the issue that documentation for internal project is garbage usually. So we're trying to fix that very quickly. So I would say that's like, before if you decide to, put it on roadmap and integrate it fully, we have to figure that out. So whenever we have this version 0, it's actually prepared for integration with all the dependencies and everything be at the right place. So we just don't have to make some weird updates because we have changed names or something like that.
Yeah, I think especially if we just adopt straight off, there's a lot of thought that has to go into that, of course, right? I think at the very least we'll be experimental looking around. I can't imagine we'll land far away, to be honest. It's some of the stuff I mentioned. For example, we the extensions that plugins export, we wrap those up in with additional like Backstage framework bits. I'm sure that can be added to, but we like to avoid like extensions to the build system if possible. That kind of changes runtime behavior. So I would be interested in solving that mostly through APIs, but it's not a requirement. It's a soft requirement. I don't know. As for way forward, it's still like we have thinking to do to figure out where we can head. I will definitely forward. Of course, I will read the RFC and forward that to other maintainers and internally.
Cool.
Do you have any other like suggested ways, like things we should look at, for example? And what are you essentially recommending that we look at adopting Scalprum as the microservice kind of framework as part of Backstages?
So yes, and the reason for that being is because we want existing modules that live in Red Hat products to be able to be plugged into the Backstage that Red Hat is developing. That's basically the suggestion here. Now it doesn't, well, I'm not gonna say we don't have to do it like that, right? It's specifically with the extension part, it's going to be difficult to not use it. Let me put it that way. Like with the micro application mount point, it's kind of easy because it's technically just a wrapper around the module federation with some bits added onto it. Right? You would lose some features that Scalprum provides, but that's fine. With the extensions themselves, as OpenShift console is using it, that would become problematic if something else would be developed.
Yeah. I think most likely that, so we will want to go look at Scalprum properly, look at the technology, look at the experience. I think regardless, we've done this in the past, looked at other solution, we'll want to back up and rethink, like just blank slate, what kind of development experience do we want, and like what top level top-down design of what this system would look like for people that build plugins and applications and so on in Backstage, and then go back and see like how well does it match and how how close is Scalprum, for example, there as well, and where can we go.
Okay.
As for ways forward, I don't know if I'll let you know when we know more to begin with.
I think like we still want to like we would like to see what VMware solution to maybe a similar problem is. That demo that should have happened today and didn't. So I think like at least for that we should meet again.
That's true.
And I would appreciate any additional discussions about the RFCs. And if we decide that we're happy with what we have for the front end, we can switch gears and start thinking about the backend's microservice architecture and plugins there, which we, like, if you remember, like during the first meeting, we decided to break it apart. So maybe we can.
I can
do
say
that.
for backend, the backend system that we've done, it does like it takes us almost all the way. I would say there's a little bit more needed, but we want to do the same thing in the backend ultimately. It's just that the front end is way further away at this point, so we're focusing there, of course.
Yeah,
but yes, that sounds good. Yeah.
Yeah. To me, like, I don't know enough about the new backend things, so to me it seems harder to achieve this on the backend side. With like as we just shown, it's achievable on the front end. So whichever way we decide to go with the front end, allowing this to be independent is a key for us. Like even if we choose to not use Sculprum, which I think would be a shame, but if we decide that way,
you're slightly biased.
I'm definitely biased. But if we like settle on a different technology, I'm still happy with that, and we can help go forward with that initiative as well. So.
Yep.
Yeah,
I'm just looking for a healthy balance of like not too much tech on our end, but also not too much magic somewhere else. When it's too, close to core. We'll see.
Yeah.
Yeah, cool. It sounds like another meeting to discuss VMware. It's good either way. Let's talk again. Cool. I'll ping Taras about that. And I'm sure he'll be able to set it up with the tool that I can't remember the name of. Anyway, good chat.
Thank you.
Thank you.
Take care. Bye.
Thanks.